education, and workforce. And each of these had what he called a wildly important priority that went along with it, which was sort of a goal to be pursued within the administration. And specifically for environment and renewables, that wildly important priority was to set Colorado on a path to 100% renewable energy generation by the year 2040 and position Colorado as a leader in the clean energy economy. Shortly afterwards, in 2019, the Colorado Evaluation and Action Lab at the University of Denver announced an open call for proposals from research teams to tackle one of the governor's wildly important priorities. The team that I was working with submitted a proposal to inventory and map Brightfields across the state of Colorado, buoyed by the enthusiastic support of the Office of the State Architect, who we had been collaborating with to develop this proposal. Fortunately, our proposal was selected for funding, and we were awarded a grant of $140,000 to build out the geodatabase and the web mapping application. So to give you an idea of what I mean when I say the word Brightfields, Brightfield is actually a term that was coined by the EPA back in 2012 to refer to the development of renewable energy on contaminated or disturbed sites, such as brownfields, that's where the name comes from, that would be difficult or costly to remediate for other purposes. This is an example of a Brightfield installation in Conley, Georgia. It's a solar power installation at the Hickory Ridge landfill. So it's basically the idea of just taking land that is contaminated or blighted or disturbed, that's difficult to remediate for other purposes, and siting renewable energy installations on it. Now, why do we want to do that? Well, one of the reasons that we chose to focus on Brightfields is because it addresses some of the inherent land use conflicts that come up with renewable energy. So when you're comparing renewable energy like solar and wind to fossil fuels, it takes about at least 10 times the land area per unit of energy to generate the same electricity from renewables as it does from fossil fuels. And because of that, there are inevitably going to be land conflicts sometimes, right? So traditionally, if you look at a lot of the existing wind and solar operations in much of the country, they're placed on what are known as green fields, meaning that it's open land that could be used for agriculture or open space or other purposes that hasn't previously been developed. So that's primarily where renewable energy has been placed before. But increasingly, there have been conflicts. There are a number of communities where farmers in particular are upset about proposed installations of renewable energy. And there have been protests in some places over renewable energy about perceived health impacts or impacts on the environment and so forth. And so brownfields help, or rather Brightfields, help to address some of these issues, because we're taking land that's already compromised and repurposing it for renewable energy. So it's land that's not green fields to begin with, and it's land that's not already being used for farming or residential development or other things like of that nature. So as I mentioned, the governor set a goal of converting the state's electrical grid to 100% renewable energy by 2040. Currently, we're at about 30% renewable energy, and that represents a doubling over the last 20 years. If you go back to 2001, we're only at about 15% renewable energy. That said, we obviously need to accelerate quite a bit to get to 100% renewable energy in the next 20 years. So Brightfields is seen as a way of helping to accelerate that movement to renewable energy. Of the 30% that's currently renewable in Colorado, about 78% is wind, which is 8th in the nation, and about 14% is solar, which is 10th in the nation. The other two that the EPA considers to be renewable are hydroelectric and biomass. We chose not to include hydroelectric and biomass in this study, partly because their siting needs are a little bit more specific and not as adaptable to Brightfields, but also because they tend to be controversial because of some of the effects on the environment, and particularly with biomass, there's a question about whether it's even should be considered renewable at all. So we chose for this project to focus on wind and solar. These are some examples of the existing operable solar and wind plants in the state currently, with a nameplate capacity of 1 megawatt or more. So you can see some of the solar and wind installation there. There's a note in particular, the high concentration along the Front Range of solar projects, and then up near the Colorado-Wyoming border and Nebraska border of the wind projects.
No surprise there.
No surprise. Right. And Brightfields are not a new idea in Colorado. There are some sites that have been repurposed from industrial or contaminated land over to renewable energy. This is a map showing where some of those locations are, but there's really only a handful. There's only 7 or 8 currently in the state. And part of the problem is that it's difficult to find some of these sites. And once you find them, it's difficult to assess whether or not they're appropriate for renewable energy. So the idea behind this Brightfields project was to create a geodatabase and a web mapping application that could help municipalities and energy developers and other stakeholders find and visualize and assess these sites. So some of the project objectives include creating a comprehensive geodatabase of all the Brightfields across Colorado. And given limited time and resources, creating a prioritized list of Colorado's 64 counties for inclusion to maximize impact. And it wasn't just based on prioritizing for maximize impact, it was also based on data availability. There are quite a few counties in Colorado, I think it was 15 or 16 of the counties that do not have a GIS office, don't have any kind of GIS data whatsoever for their counties. And so some of those counties were eliminated in that process. The process that we went through to prioritize the counties, that was a whole other project that I could spend an entire seminar on, but I won't today. Just know that it was a process that we went through that we carefully considered a lot of different criteria in choosing which counties to include. We also wanted to identify Brightfield parcels using a set of replicable criteria. Populate the identified Brightfield parcels with attributes that cover site analysis metrics and renewable energy potential for wind and solar. And then build a user-friendly web mapping application interface with functionality that provides for the display of the Brightfields as parcels of land rather than points. That's an important distinction I'll talk a little bit more about in a moment. The ability to search for specific sites or geographic areas, the ability to filter Brightfield parcels based on useful attributes, the ability to visualize those parcels overlaid with other useful site and contextual information, and finally, to be able to export a list of identified parcels for further investigation. And I'll be demonstrating all those different aspects of the functionality in a little bit here. In order to advise us, we formed an advisory committee that we checked in with periodically, made up with people from state and federal agencies, community organizations, conservation organizations, energy consultants, energy developers, industry associations, utilities, and so forth. And all of these people formed the advisory committee, and we went to them whenever we were trying to sort of figure out what would create the maximum benefit from this particular project, because really it was about, making this useful for the people who are actually out there in the field developing these projects. And so we wanted to make sure that it would be useful for their needs. In terms of the CSU-based project team, I led the project team. Sophia Lynn worked with us quite a bit from the Geospatial Centroid, as did Joshua Railing, Luke Chamberlain, and Mark Bergoli. They were all helping. Sophia Lynn was overseeing the interns at the Centroid, and then the others were helping to assemble the geodatabase. And then David Puckett was our web developer. He has done a lot of work with the Centroid and CSU. He has a small company called Bright Rain Solutions that does specifically geospatial-based web development. So we worked with him to develop the web mapping application. We did look at a couple of precedent projects before we got started to see like what was out there and what had been done already. The two specifically that we looked at were the EPA's repowering mapper. RE is capitalized because it stands for renewable energy. And then also the Massachusetts Brownfields to Brightfields, or B2B mapper. At the time when we're creating this, those were the only two precedents that existed. Since then, Hawaii has also created their own mapper. But these were the two that we were looking at as precedents to kind of glean what we could, some of the best practices from those, and implement those in our own web mapping application. The important thing to consider, though, is that the Colorado Brightfields project is specific to Colorado. It's looking at the needs of the stakeholders in Colorado, at the types of contaminated land that we have, and considers a much broader swath of different types of contamination than, for example, the federal mapper does. And it's really kind of focused on the needs of Colorado. So the first precedent is the EPA repowering mapper. It was developed to encourage renewable energy development on sites from federal databases. Primarily, it relies on the EPA's federal database of brownfields across the country. It identifies sites as 4 types of renewables: solar, wind, geothermal, and biomass. As I mentioned earlier, those can be the ones, particularly biomass and geothermal, can be somewhat controversial, but they included those in their database because, according to the federal government, those are all renewable. The data is provided only as points and has limited attribute data. So that was one of the things that we wanted to remedy in our version of the mapper, is to provide polygonal data and not just points. There's also no overlay data in the EPA's mapper. So basically, you just see points on a map. You can see the attributes of those points, but that's it. There's no other information that you can look at in that system. And then the other precedent was the Massachusetts B2B mapper. That one was launched back in 2011. It only tracks 2 types of contaminated sites: EPA repowering sites, which we just saw in the last precedent, as well as Massachusetts Department of Environmental Protection contaminated sites. The data, again, is provided only as points and has limited attribute data. There are some limited overlays available on this site, but only a handful. And so looking at these 2 precedents, we wanted to build on those and create something that would be more useful for our stakeholders and provide the information that they needed. So an important distinction about our mapper is simply that we provided information on a parcel-based or polygonal data approach. So instead of using just points to identify sites, we're actually using the property lines of those properties to define them, so that stakeholders can look at them, assess them, understand sort of the land area that they're dealing with, what the geometry of that parcel is, the topography, and other sorts of characteristics. So it seems like a small thing to say, but it's actually like a huge improvement in the usability of the system for the people who are going to be using it. Another thing to keep in mind is that using that parcel-based approach meant that we had to build this out by county, because parcel data is generally managed by county assessors' offices. And so that parcel data is available on a county by county basis. So as we're building this out, it was inherently going to have to be based on the counties that had that data available. So these are some of the data sources that we use to identify Brightfields across the state. All of this, of course, was point data and had to be coordinated with individual parcels so that we could figure out what point went with what parcel. It was not always easy. A lot of times when you mapped out the EPA data, the points landed right in the middle of the street and were not on a parcel, and you kind of had to figure out which one it went with. Joshua Railing, by the way, was like huge in helping us figure that out. He spent a lot of time on that. So a shout out to him. I don't know if he's on the call today, but he was a huge benefit with that. But we took data from the EPA, the Colorado Department of Public Health and Environment, or CDPHE, the Division of Oil and Public Safety, and the Colorado Division of Reclamation, Mining, and Safety. And this just lists out some of the different types of programs that track contaminated sites that we were pulling information from to identify what sites would be considered Brightfields. So there are things like federal and state brownfields, Superfund sites, of course, landfill methane outreach program sites, petroleum brownfields, inactive mines, closed landfills. And then we also added vacant industrial land, which was identified not from any one database, but by basically using land use data and building data to identify sites that were currently zoned for industrial uses, but were vacant. So these were the types of sites we were looking at. And once we had identified those sites, the next thing was to populate them with attributes, right? The kinds of attributes that an energy developer would need in order to figure out whether or not the site's going to be a good fit for their particular project. So we had legal and regulatory information that, of course, dealt with, information about the site itself, the address, the county it's in, the parcel number, the owners, the zoning, easement types that might affect that land, whether or not it's in an opportunity or an enterprise zone, which provide tax credits for economic development. And then the Brightfield type, meaning what type of contamination or what federal or state program led to that site being identified as a Brightfield. Then we also looked at the physical environment, right? So we were looking at factors like the land cover on the site, the area of the parcel in terms of the acreage, the perimeter of the parcel, the geometry of the parcel. That's really important. If you look at solar and wind installations, typically they're laid out on a grid because that's efficient for, in terms of sort of packing in the most amount of energy generation in the smallest area, but also for servicing the equipment and so forth. So we came up with a measure for parcel geometry. Existing structures. So we looked at whether or not there are existing structures on the site, how much area those took up so that developers could have an idea of what's the available space left over. Tree canopy, obviously important if you're doing solar development. You don't want, a lot of tree canopy that's going to shade those photovoltaics. So we include that in there, and then distance to the nearest road for site access. And then in addition to that, we also populated them with attributes about renewable energy siting criteria. So we looked at renewable energy potential like direct normal irradiance, global horizontal irradiance, wind speed at 80 meters. 80 meters is the most common height for wind turbines. So we took wind data for 80-meter height above the ground, utility service areas, distances to nearest electric transmission lines and substations, because obviously if you're generating electric power, you need to plug that back into the grid somehow. So being able to access that is important. But also looked at things like the terrain, like the slope angle, the slope aspect, what direction does that slope face, the contours, and then also looking at ecology in terms of sites that developers might want to avoid because of ecological sensitivity. So like habitat areas, critical wildlife habitat, migration corridors, conservation land, and wetlands. So there's quite a lot of information and analysis on the front end that went into populating all of these Brightfield parcels with their attribute data. And then these are some of the web mapping capabilities that we ultimately were able to include in the web mapping application, which I'll be demonstrating in just a minute here. So you can search by name and location. You can filter Brightfields based on various attributes. There are tools to link to the assessor's data. So for each parcel, you can link directly back to the assessor's website and see all of that assessor information. There are measurement tools on there for distances and areas. You can print out the maps. You can download the parcel data as a spreadsheet. And then you can also visualize lots of different types of overlays that provide additional information about that particular site and its context. I won't read through all of those, but I will instead demonstrate some of those. So now we'll jump into the map, and I'm going to, I think I might have to change my screen share. There we go. All right, so let's go to here. All right, good. Okay, let me share this. Yeah, we'll try it out. And where is? Here we go. All right, so the site lives at brightfields.colorado.gov. We worked in collaboration with the governor's office to put the project together, and it's hosted on their servers. So it's got that nice colorado.gov web address. This is just a kind of a standard disclaimer splash screen that comes up when you open it, and then links to resources, user guide, FAQs, and so forth. Oops, I'll hit OK here. All right, so first I'll begin by zooming out a little bit. So this begins by showing all of the identified Brightfield parcels as points, partially because you can't see polygons when you're zoomed all the way out at the state level. But you'll see if we zoom in, like let's zoom up here into Weld County. Once you get past a certain magnification level, they automatically change over to parcel outlines so that you can actually see what that piece of land looks like instead of just seeing a dot on a map. You can filter these over on the left side of the map here. So at the very top of the filters, it shows the number of Brightfield parcels that are currently included in based on those filters. So right now we have 4,753. And again, I'll just point out if I zoom out, whoops, I rotated the map a little bit. Let's get back to north up. There we go. I'll just point out that this includes 10 counties because with the time and resources we had available, we had to make decisions basically about the sort of proof of concept and which counties were going to be included in the initial rollout. So these are the 10 counties where you see the dots here. I can filter based on county if I want to, right? So if I just want to see, these are the 10 counties listed here in the county window. So if I just wanted to see everything in Arapahoe County, I could click on that. And you'll see it filters it down just to show the parcels in Arapahoe County. And up here, the number is updated to show that there are 203 Brightfield sites in Arapahoe County. If I want to do multiple counties or any multiple filtering criteria, I can just hold Control. So if I want to do Arapahoe and El Paso, I'll hold Control to select multiple, and you can see those points show up on the map. I can also filter by Brightfield type. These are all the different programs and criteria that we use to identify the Brightfields based on contamination or use. We can filter based on utility service area. So if a particular utility provider wants to develop Brightfields and they only want to see the Brightfields that are in their service area, then they can filter based on that. You can filter based on city and county. You can filter based on whether or not those sites are included in an opportunity zone. So let's add opportunity zone to this. And you can see now it's gone down to 308 parcels that are in Arapahoe or El Paso and an opportunity zone. You can also toggle on and off whether or not they're in an enterprise zone. I don't know if any of these are in both. Looks like most of them, 301. And then you can also filter based on parcel area and wind speed, right? So if you need a minimum area parcel in order to develop, let's say, a utility scale installation, then you can filter for that by dragging the slider or typing in a number up here, right? So this is in acres. If I say I only want to see sites of at least 100 acres, then it filters it down. Now I only have 5 sites that match all of those criteria, right? So as you add more and more criteria, you get obviously a smaller and smaller set of parcels, right? You can also, here, let's clear these. There is a button up here to reset the filters, so I can clear all those filters. You can also search up here, right? So if I wanted to search for sites that were near, let's say, Mile High Stadium. Right? It will take me to that location, and then I can see the all of the Brightfields around that particular area. I can also search by the name of the particular site that I'm looking for. So if I wanted to look at the Lowry landfill, go here, and it'll take me to Lowry landfill, and you can see that's one of our brownfield sites, right? And once you select the site, you'll see that we get a pop-up window that shows all the attribute data for that particular site. So here we have information about the zoning, the parcel number. We have the Brightfield type. In this case, it was identified from the EPA's list of Superfund sites. We have the notes here is kind of an open field that pulled data from the federal and state databases about the nature of the contamination on that site. So there's a, you can see that there's a web link here that you can go to get additional information about the contamination. You can see what utility service area it's in. You can see the parcel area and perimeter, and then that shape index is the number I was talking about earlier that gives you an indication of the geometry of the parcel. So this is actually a concept that's borrowed from landscape ecology to measure basically the regularity in terms of the shape of an area of land. So if this was a perfect 1.0, that would mean that the parcel was a perfect square. Anything above 1 is getting less and less square. So numbers a little bit above 1, like this one is 1.25, and you'll notice that's kind of an elongated rectangle. Some sites, if I zoom out here, let's pick a site that's really convoluted. Like some of these sites up here have very convoluted boundaries. And if I click on that, you'll notice the parcel shape index is 1.91. So if it gets closer to 2 or even above 2, then it's a very unusually shaped parcel and might not be a good choice for laying out solar panels or a wind farm. And then, of course, there's other information about the types of land cover on that site, the canopy area in square feet, so how much of that site is covered by tree canopy, whether or not it's in enterprise and opportunity zones, and then all of the renewable energy siting criteria. Right, so let's go back to that Lowry landfill. Right, and I'll just use this as an example here. So we have this site highlighted. Here's its attribute data. Up here at the top for every one of these sites, there's a link back to the county assessor's data. So I can click on that. And that goes directly to the county assessor's website, provides all of the information for all of the different tax years for that particular parcel. They have their own parcel map that you can look at for that particular site. But it gives, again, it's sort of saving the work involved in trying to investigate these sites and go through sort of a due diligence process in determining whether or not the site's appropriate for building a renewable energy development. And it's really, this whole site is built around the idea of streamlining those operations. So let's go back to Brightfields here. I'll show you some of the other capabilities here. You can, of course, toggle the base map. That's pretty common on a lot of online ArcGIS maps, but particularly important for this in order to be able to see what that piece of land looks like, whether there's anything already developed on it. And then there's a whole series of overlays that we have here, right? So electric infrastructure is one of the most important. And this one includes electric substations and electric transmission lines. So if I turn that on, and here, let's get rid of that. Let's close that window for now. And we zoom out, you can see the electric transmission lines here in pink. And then you can see substations are little boxes, which here's one up here, right? And all of this data is clickable, right? So for example, I can click on the substation here, or whoops, I guess I got the transmission line. But you can see the voltage on the transmission line, the voltage class, what substations it's connected to. And then you can click on, if I click accurately enough here, there we go. We can get the substation and you can see the minimum and maximum voltage of it, where it's located and so forth. So this is the kind of information that renewable energy developers are really interested in when they're trying to make decisions about a site. We also have other overlays we can do. So if I go back in here, we can see enterprise and opportunity zones. So if I click on enterprise zone, we'll see if any of these are in enterprise zone.
Since you're talking about, we had a question in the chat about what are those?
What
opportunity and enterprise zones?
Oh, so those are state-run programs that provide tax incentives for economic development. So if you're creating a new renewable energy development and it's going to create some jobs in the building and running of that installation, then it can count, if it's in a particular part of the state, it can count for tax credits. So I will zoom out here because there aren't any right there, but you can see some of the crosshatch here. This is easier to visualize on the gray map here. And this is where it's starting to slow down. Here, let me turn off the electric infrastructure here, see if that speeds things up. But you can see it started rendering it here with the enterprise zone. And let's just turn that off. There we go. There we go. There's some more. And then opportunity zone is just a crosshatch in the other direction. So this area right here, all of the parcels in this area are both in an enterprise zone and an opportunity zone. So they would count for two different types of tax credits if a development happened in those areas. We also have hosting capacity. This is only available for Excel because they were the only utility who actually provided that data to us. But it shows the capacity of the existing electrical infrastructure. So in this case, areas that are red are already completely at capacity. They can't take any more electrical power generation. Areas in green have plenty of excess capacity, and those are better places to plug into the grid. We also have things that would make factor into making a decision about development, like FEMA flood hazard areas. I should probably zoom in a little, right? So you can see the FEMA flood hazard areas. And these have keys underneath as well. So if you just expand it, it says like what kind of flood zone it's in, for example. Co-map land ownership, that's a big one. I won't turn that on right now. We have rivers and streams here, so you can see water bodies that might impact whether or not a site is appropriate for development. And again, some of these, I apologize, some of these are going a little bit slow. Zoom tends to slow down the interface for some reason. Let me zoom in on a site here. because that usually goes a little faster if you're not showing as much of the screen. I don't know if there's I don't think there are any rivers or streams near there. Wetlands, if there are any. Don't think there are any near this site. Those look like lakes right there, so those should come up. There we go. So we have lakes and ponds. And then really useful also is contours. And this is probably the biggest data set on the whole site. So we'll give that, there we go. Right, so we have contours on here so that developers can get an idea of like what is the slope, how much of the area is flat, if that's an important consideration, what is the direction of the slope and so forth. So these are all criteria that could help make somebody make a decision about whether or not a site is appropriate. And then we also have conservation easements on there as well, if there are any that apply to that site. You might see some if we zoom out here. Nothing. There are definitely some conservation areas. I think they're just not, yeah, it's thinking. So you can see the little bar going by under here. So I'll just turn that one off. But if you want to try this on your own computers, you'll get hopefully better performance out of it than over the Zoom connection. So in essence, that's the mapper. It also allows you to do basic measurement tools. Down here at the lower left, there's area and distance measurement tools. This print button allows you to print out whatever's currently on the screen. So you can print out the map that you're currently looking at. And then finally, you can download. So if you hit this download button up here, it'll download all of whatever parcels you have selected. You can't download the entire database because it maxes out, I think, at 400 or 500 parcels. So it's more useful if you're filtering out which parcels you are interested in. And then you can export those to a spreadsheet so that you have all of that information in one place and you can do a deeper dive into those individual sites. So I will stop sharing that, and then I just have one slide left here. Let's go back to share screen.
We have a few questions in the chat.
Oh, okay, great. All right, I don't even know if I'm sharing the right screen. Are you seeing my presenter screen?
We're seeing the PowerPoint like working.
You're seeing that?
No.
Oh, okay, let me reshare. The joys of Zoom. Okay, let's do that again. Share. I think. Yeah. Oh, well, I'll just go to my last slide. It doesn't matter if it's in presentation view. All right, so in conclusion, when we rolled this out at the end of the process of building out those initial 10 counties, we had an overwhelmingly positive reception by our project partners and the stakeholders. Some of them are already using it for the counties that we built out to identify Brightfield sites that they can potentially build out. One of the things that would help accelerate this process is if the state had incentives to drive renewable energy development on these types of sites. Currently, the state treats Brightfield sites as they would any other type of renewable energy development. But if there were some kind of incentives to rebuild on these contaminated sites, then that would certainly help move these projects along. Massachusetts, for example, they provide substantial tax benefits to energy developers who build on landfills and Brightfields and so forth. Currently, we're seeking additional funding to complete the project for the rest of the state. So we've done 10 of the 64 counties, and that leaves 54, and then about 15 of those have no parcel data. So that means that we have about was it 40 or so that we still need to build out. So we're looking for that funding so that we can finish the project for at least as much of the state as possible. And then I'm going to be sharing this project a number of times this year. This is actually the first time I'm sharing it, so you guys are first in line to see it. But I'm also going to be sharing it in a departmental seminar for horticulture and landscape architecture, and then at 3 conferences this year. One is a landscape architecture conference, one is a GIS conference, a Geodesign Summit, and one is a Brownfields conference. So getting different types of audiences and getting their feedback and sort of getting the word out about this project. So that's where we are. And thank you for listening about the project. And does anyone have any questions?
Thank you so much, Scott.
Thanks.
That was really cool. We have a couple of questions on chat, and are there questions in the room as well? Well, if you think about it, we'll start on chat. All right.
All right.
U77U asked a few questions, so thank you. Where am I? What has Colorado established as the min or max distance for solar tie into electric substations?
To my knowledge, they haven't established min or max distances. And I am not an expert in, in electrical energy grids. So I do not know that they actually have established minimum or maximum. When we're working with our advisory committee, which included people from industry, they basically indicated that you can tie in basically anytime that there's a substation available. It's just that the further away it is, the more expensive it is to build out that installation. And so that's, obviously a consideration in terms of the cost of that particular development. No, that's fine.
Okay, and then also from U77U, is establishing a Brightfield site considered a qualifying environmental mitigation strategy pertaining to the EPA's EIS or EIA, Environmental Impact Statement?
Okay, so sorry, say the question again. Is it considered a...
Is establishing a Brightfield site considered a qualifying environmental mitigation strategy? And if you
I have no idea. I have no idea. That's an interesting question. I kind of doubt that it is, though. I don't, because it's not necessarily mitigating the site. It's just using it. And part of the attractiveness of those sites is for renewable energy is that since you're not putting housing or a school or something of that nature on there, that the requirements for mitigation are a lot less, and it makes it a lot more economically feasible to develop those projects on those sites.
Yeah, so due to the complexity of the website, I assume that maybe more than one programming language are being used. But what are the main programming languages that the website uses?
I know, so I didn't actually program the website. That was David Puckett at Brightfields. Oh, he is, okay.
Yeah. David, do you want to unmute and answer Abdullah's question about what types of programming languages and tech went into the web map?
You guys, I thought I was going to be able to just slink in the background here.
I'm putting you to work.
Hey, David.
Hey, nice work. It was a great presentation. I'm sorry, what's the question? I didn't hear it.
What programming languages and tech went into the web map?
So this is JavaScript. This is a completely front-end web application, and we use the ArcGIS JavaScript API. I'll go into the most technical depths if you want, but that's the quick and easy answer.
Yeah, and if you ever want to know more, I can Okay, what other questions? Maria.
Yeah, just generally, how long would it take you to do the rest of the counties? Like, it just seems like so much work goes into this.
Yeah, it was actually, so the vast majority of the work was just figuring out the whole process for how to do this. And so as I was compiling this and working with the interns at the Centroid, I basically assembled this like 26-page instruction manual for how to identify Brightfields as we add new counties. So that was most of the time went into just figuring out how to do all this. Now that's figured out, I could probably get a county done if I was doing it myself, like in 8 to 10 hours. So figure, filling out the rest of the state isn't like, a monumental task. It's very doable.
I had a related question about how automatable this all is. It sounds like it's pretty automated, and then how is it? Like, how would you go back and do it in 8 hours? What?
Yeah.
Model builder, code, or what?
Model builder is definitely helpful. So unfortunately, some of it doesn't always necessarily, and I don't have a huge amount of experience with model builders, so my models are pretty simple. But there some of the data sets, you get what you get when you're working with data sets that come from other people. So the data isn't always consistent. You always kind of run into like odd data points and things like that. They kind of have to work out manually. But there was some model builder, and a lot of it was just kind of the manual work of, an ArcGIS Pro of doing the, basically it's like seeing where points land on parcels. That's the biggest part of it, is like taking all that point data and matching it up with the parcel data and getting those identified.
And we'll do one more question, and then I'll let you go because it's officially Connor.
So you said that some counties just didn't have any parcel data. Do you have any plans to work with the counties that have seen that data, or are you just gonna what's the plan forward with that?
Yeah, so that's an interesting question, because some of the counties I searched for, and I found that there were commercial operations who had mapped out the parcels. They just hadn't shared it apparently with the assessor's office, or at least if they had, the assessor's office chose not to share it. But some of the counties I contacted, many of them just didn't respond. Like I just never got an email or a call back. And the ones that did respond, some of them just said they didn't have that data, but that they would contract with a commercial organization to map out that data and create a feature class from it. So that would be an additional expense in sort of building out the database if that comes up.
Officially class ends at 4:50, so if you have to go, I'll let you go. But if you have questions still, Sarah, you have questions? You have a few minutes?
Sure.
Okay. So yeah, stick around and ask more questions or leave if you want to.
Great.
My question is, this is obviously a very well thought out process with going through, I mean, every question that I came up along the way, you answered as the presentation went
Great.
on. Can you talk a little bit about like your stakeholder process of like getting people together and finding out like what data did you want to include? What was most valuable and sort of narrowing down that list?
Yeah, so at the outset of the project, we had 2 meetings, and they were kind of long, like 4-hour meetings that we had with our advisory group. And I will mention that when we started this process, it was like January and February of 2020. So it was before COVID. So we all just got together, we went down to Denver and we all got together, and there were 30 of us in a room, and we broke out we had breakout groups. So there was one group that was just looking at how do we prioritize which counties to include. There's another group that was looking at what's the most useful types of parcel data in making a decision about developing a site. Another group that, what renewable energy criteria do we want to include? So we relied heavily on that advisory committee to give us a lot of that information. And then we checked in periodically with them as we were developing the geodatabase and the application to make sure that, we're still in line with what they needed.
So did that include a lot, like county officials, industry people? Was it just a mix of all kinds of different?
Yes, yeah, it was state and federal. We had people from the EPA. We had people from the Colorado Department of Public Health and Environment. We had industry consultants. We had representatives from some of the utilities. We had community groups, we had some people from municipalities. So it was a pretty broad cross-section of potential stakeholders.
Yeah, this, I mean, obviously it's been very well planned, very well organized.
Great, thank you.
Thank you.
Yeah, this project I saw that thing, combined over 100 data sets, and I was kind of, aware of the project when you were doing it with the Centroid,
Right.
but I never saw the whole, when you showed that, I was like, that's a lot of.
Yeah.
All right, any questions?
Yeah, I noticed, excuse me, I noticed that you had a dot over Fort Carson. Is there, bright sites there?
Let's take a look.
Oh, there's a, near my apartment.
Let's see. Let's go back to the mapper here. I'll share this. All right, Fort Carson. Let's see what's there. Okay, so there's this site here, which is it's zoned as agricultural. It's it just has an address. It's a closed landfill. So that's what that site is. So, and that's, that's obviously like an attractive place to put solar and wind, because it's otherwise it's just kind of a capped mound of earth. And that's what Massachusetts is primarily focused on, actually, is reusing those landfill sites.
So what's stopping you from using that site? Is it,
Oh,
DOD blocking you?
nothing's stopping me. I don't develop renewable energy. I just provide the tools so that other people can make those decisions. So in terms of why it hasn't been developed yet, I have no idea. That's maybe there just hasn't been interest in that site yet. I don't know.
So if that area was to be processed,
Mhm.
would you be working with an organization such as SEMA?
So I probably wouldn't be working with them at all unless they had questions about the actual data in the mapper. Like this is just a screening tool to help them find appropriate sites. Once they find an appropriate site and they want to dig deeper, that's kind of on whoever's developing that installation.
But I could see someone being involved though. It sounds like something very much.
Oh, no, that was answered.
Right.
Yeah, the goal of this project was to identify the areas and then release the information out into the wild for
Yeah.
the other folks to, pick it up and share it.
Yeah.
I had other questions that you bring up here. There were questions that would have been good for like new students. So I'm gonna ask them anyway, just so I know the answer. What coordinate system was used for all these calculations? Because you're doing so much with distance and area.
Yes. So it was UTM 13 North. Yep.
And then I had one other question. Oh yeah, the shape index, is that like a perimeter to area ratio?
It is indeed.
Straight up.
It's a ratio, and basically the way it works is that you're comparing the ratio of the actual site to the ratio of a perfect square of the same area, right? So essentially you take the total area, you find the square root, and then you multiply that by 4, and that gives you, what the perimeter would be on a perfect square. And then it's a ratio of what the actual perimeter is to that perfectly square perimeter. And the further it gets away from being a square, the higher the number gets.
I just had in my class as a way to look for slivers.
Mhm.
But I have a new example now.
Yeah.
We had one more question from U77U. Are the opportunity enterprise zone boundaries, are they redrawn around the same time voting precincts are drawn?
No, I don't think those are as much of a gerrymandering type of issue. And those are determined at the state level by, like I think it's the Office of Economic Development or whatever it is that kind of decides those. And they have a whole bunch of criteria that go into determining what makes an enterprise zone or an opportunity zone based on like income and number of businesses and that kind of thing.
Cool. All right, well, we'll call it here then. Thank you so much. for
Great.
that. Thanks everyone for coming.
Thank you, everyone.
And, yeah, thank you.
Great.
And David Puckett has final words. He says, fantastic presentation, Scott. It was great to work with such a talented and dedicated team. We'll build the future, y'all.
Awesome. Thanks, David. Great hearing from you.
Thanks, guys. Great presentation.